Welcome to the video on bond enthalpy. All right. Now, enthalpy isn't a word that we've talked about in class yet, but it's actually not that hard to understand. All it is the energy required to break a covalent bond. All right. So it's a very straightforward, simple definition. How much energy do we need to snap that covalent bond? But what you have to understand is, if we're talking about energy as a positive to break a bond, when a bond is formed, then we have to talk about negative energy or energy being released. Okay? Now we haven't talked a whole lot about thermodynamics, but when there's a positive energy, that means this thing that we're talking about is taking in energy. Its energy is increasing. That's why it's positive. When bonds form, this is a negative energy. The system or the compound we're talking about is getting to a lower energy state. It is releasing that energy out into the universe. So here are some bond enthalpies for different bonds. Here we have a carbon-carbon single bond, carbon-fluorine single bond, and a carbon-iodine single bond. Here are the bond enthalpies for those bonds, and you can see that they're changing, all right? Bond enthalpy is related to bond distance. The shorter the bond, the stronger the bond. And here, fluorine and iodine is much larger than fluorine. Therefore, the bond enthalpy of a carbon-iodine bond will be less. It takes less energy to break it. You can also see that our carbon-carbon single bond, 348, as compared to the double and triple bonds. As we start adding bonds, our bond strength increases. Okay, now the whole idea of this is for a situation like this. We're going to talk about methane burning in oxygen. All right? So here, this is methane. And you can see, well, when methane reacts, those carbon-hydrogen bonds break. So, how many carbon-hydrogen bonds do we have here? There's 4. Hopefully you can see the 1, 2, 3, 4 carbon-hydrogen single bonds. Each one of those single bonds requires 413 kilojoules to snap or to break. Well, there's 4 of them, so to break all 4, that requires 1,652 kilojoules. Here for O2, each O double bond requires 495 to break. There's 2 of them, because we're going to need 2 O2 molecules. So 2 times that amount gives us 990, and we add those up because those are on the left-hand side of the arrow, we get 2,642 kilojoules. That value is positive because we're breaking those bonds. That's how much energy needs to go in order to sever all of those bonds. If we move over here to the other side, when methane burns, we create carbon dioxide here and water. We form a carbon-oxygen double bond and another carbon-oxygen double bond. So our total number of carbon-oxygen double bonds formed is actually 2. All right, not so bad so far. So 2 times negative 799 gives us negative 1598. Now that value is negative because those bonds are forming, they're releasing energy. Here for water, we made 2 waters. Each water has an oxygen-hydrogen single bond, and there are 2 of them in each water, but we have 2 waters. So our grand total of oxygen-hydrogen bonds that we make are 4. Each one of those bonds releases 463 kilojoules. So if we have 4, negative 463, gives us a grand total of negative 1,852. And we're going to add up everything on this side down here. So for all the bonds formed, we get 3,450 kilojoules released. So we have bonds formed, bonds broken. And in order to get the overall change, what we're going to do is add those 2 values together, which I've done here. Right? 2642, which we get from bonds broken, negative 3450, which we get from bonds formed, and we end up with negative 808 kilojoules. This is the total energy change of this reaction or this system, and this makes sense. If that system, when methane is burning, you guys have used the Bunsen burners, when methane is burning, it is emitting energy. That whole system is losing energy, and we'll feel that as heat. Hopefully you realize that when a Bunsen burner flame is on, it's very warm. So this is bond enthalpy, all right? It's very straightforward. Try the practice problems on the practice sheet, and you're going to find that it's not that hard.